All right, here we go. Day 2 of solving logarithmic equations. Our goal, to solve logarithmic equations. Similar to yesterday, but we are going to continue to kick the difficulty level up a little bit so we can become advanced algebra students. So are we ready? I hope so. Yeah, let's do it. Thumbs up. All right, so here we go. We're going to deal with situations where we have log on one side of the equation. And when we see only one single logarithm on one side of the equation already isolated, remember, isolate first, but once it's isolated, then all we simply need to do is change into exponential form. Once we convert to exponential form, then we solve it like we would solve any other equation. So I'm going to ask you to put me on pause and convert this to exponential form, check back in with me, and then we'll continue to solve from there. So go ahead and put it on pause and then check in and see if you converted it correctly. Okay, so hopefully you saw that 5 squared equals 2x plus 1, and now we know 5 squared, so let's solve this for x. Put it on pause and check it out. Alright, looks like when you use the algebra you get a value of 12 for x, and I plugged it back in over here and it verifies. You do want to make sure you can't take the log of a negative number, so you want to make sure that when you plug your number back in for x that you don't get a negative value, because you can't take the log of a negative number. So you do want to consider that as you move forward. Okay, please convert number 2 into exponential form. Check back in. Does your answer look like this? Yay for you! Alright, now we need to solve. So let's consider 36 to the 1/2. What is 36 to the 1/2? No, it's not 18. Yes, the 1/2 power means square root of 36. So that equals 2x minus 3. And since we know the square root of 36, no need to make it any more difficult than it needs to be. 6 equals 2x minus 3. Add 3, divide by 2, and we get x equals 9/2, or 4.5. See if I multiply by 9/2. 18 over 2 is 9, 9 minus 3 is 6. So it doesn't give us the log of a negative, so we can find our final answer to be 9/2, or 4.5. Not too bad when the log is only on one side of the equation. Get it isolated all by itself, convert to exponential form. Alright, here we go. We kind of have only one log. Well, we do only have one log, but it's not quite isolated. So notice that this is -2 times log base 9 of -2x. So what we want to do is we want to isolate the radical. Not the radical, the log. So I'm going to divide everything by -2, and then I have to do that to the other side as well. The -2's will cancel, and I'll have log base 9 of -2x equals +3. Now I can convert, because I have a log all by itself, convert to exponential form and solve for x, and you will get a rather large number that doesn't reduce. But go ahead and give it a try. 9 to the third equals -2x. 9 to the third is 729 equals -2x. Divide by -2, and there's our value of x. Let's see how number 4 looks. Again, anytime throughout this, put me on pause, do your work, rewind, I don't know if you have slow motion, but rewind, do it again, listen to me again, see if you can use all your resources available. Here we have for number 4, we have only one log. It's already on the left hand side, but it's not isolated. If it was isolated, it would be only that. But it's not only that. We have this -6 over there, so I want to move that -6 over to the other side so that I can isolate my logarithm. So I add 6 and I add 6. I now get log base 4 of b minus 6 equals 1. Now in order to solve this, convert to exponential form and solve for b. Put me on pause, give it a try, check back in. So let's see how that worked for you. B equals 10 And does it make sense that log base 4, let's see, what's 10 minus 6 of 4, minus 6 equals negative 5? Ooh, where are you going? Negative 5. Get out of there. So let's see, log base 4 of 4, 1 minus 6 is negative 5, so that checks. So my final answer is B equals 10. So not too bad. When you only have one logarithm, simply isolate it, get everything else over to the other side, and then convert to exponential form. But what happens if you have logs on both sides of the equation? Both sides of the equation. Well, what we're going to try and do is eliminate the logarithm. Now, how can we eliminate the logarithm? Well, we're going to use the idea that if I have a, I need a marker. If I have a to the log base a of x, how that equals x. So I'm going to keep that idea in mind as I move forward. Here, log base 3, that's nice. So what I'm going to do is I am going to make these my exponents. So I'm going to go 3 to the log base 3 of 2x plus 4 equals 3 to the log base 3 of 4x. Now, why did I use 3 to raise these two? Well, because the 3 as a power, as a base to a power, and log base 3, those undo each other, and I'm simply left with 2x plus 4 equals 4x. Solve that and check back. What do you think? The algebra worked out for you? 2x plus 4 equals 4x. Subtract 2x, divide by 2, you get x equals 2. When you plug it back in, 2 times 2 is 4, plus 4 is 8. Log base 3 of 8 equals log base 3 of 8. So it checks. Let's try another one. No base, so we know it's base 10. Base 10. Log base 10 of x equals log base 10 of 5x minus 24. Yeah, you're right. X has to equal 5x minus 24. I'm going to show it though by raising them both to the from the base of 10. So 10 to the log base 10 of x equals 10 to the log base 10 of 5x minus 24. 10 to the log base 10 cancels out. 10 to the log base 10 cancels out. 5x minus 24. Solve for x. So you're going to subtract 4x, negative 24, divided by negative 4x equals 6, x equals 6, 6, 5 times 30, minus 26, check. Alright, x equals 6. Good. Let's keep working. Alright, you try this one. Now notice that we have a quadratic, so we should expect two different answers. But go ahead and try this one with log base 10s and see how it goes. Check back in with me when you're done. Okay, well, after all that work, you end up with 13p minus 2 equals p squared plus 40. And now that you see that, you have a quadratic. Use that quadratic by setting it equal to 0, so I moved 13p over by subtracting 13p. I added 2, and I end up with the quadratic p squared minus 13p plus 42 equals 0. That turned out to be factorable, and I got values of p that were equal to 7 and equal to 6. And when I considered plugging them back in for p, both of these are going to give me positive numbers. So this solution checks. P equals 7. P equals 6. So you can see when you have logs on both sides, raising them as exponents to the base of whatever this base is a good way to get rid of the logarithms. So what happens if you have logs on the same side of the equation and there's a number on the other side or something on the other side? What we hope to be able to do is condense logarithms, using properties of logarithms. And then once we condense them down into a single logarithm, then you convert it into exponential form and solve. And then always remember that you should be checking your answers when you're done to make sure that you don't take the log of a negative number. Here I see that I have addition of two separate logarithms. So I'm hoping to use the property of logarithms to write them as a single logarithm. Now the fact that they're both base 2 allows me to do that. So that gives me log base 2 of, well, addition turns into multiplication. So this becomes 5 times x minus 1. Log base 2 of 5 times x minus 1 equals 1. Let me erase this. So now I have, and I can distribute that, and I will before I convert. So now I have log base 2 of 5x minus 5 equals 1. What I want to do is convert this into exponential form. So 2 to the first equals 5x minus 5. 2 to the first equals 5x minus 5. Now solve for x, add 5, divide by 5. So our final answer is x equals, add 5, divide by 5, 7/5. And if I think about plugging that back in for x, 7/5 is greater than 1, so that's a positive number up there. So there is my final answer. So we used properties of logarithms to change it from the sum of two logarithms to the product of a single logarithm, and then I converted into exponential form, and then I solved for x, took my answer, plugged it back in to make sure I wasn't violating any domain restrictions. Not too bad. See if you can work on number 9, changing the subtraction into division, and then go from there. Try it on your own. I got x equals 24. What did you get? Hopefully it's the same thing. Alright, I converted subtraction into division, so I got log base 9 of x plus 3 divided by 3 equals 1. Converted to exponential form, 9 to the 1 equals x plus 3 over 3. 9 to the 1 is simply 9. To get rid of my fraction, I multiplied both sides by 3, multiplied both sides by 3. These 3's canceled, leaving me with just x plus 3. And over on the left-hand side, I ended up with 9 times 3. So 27 equals x plus 3. Subtract 3, x equals 24. If I plug in 24 here, it doesn't give me a negative, and indeed it does check out. So x equals 24 is my final answer. Okay, I have about 2 minutes left on my recording, so hopefully I don't run out of time. Here you see addition of two separate logarithms. Condense it down into a single logarithm. Convert it to exponential form. Come back and check your answer. Check in with you in another second. Did you get log base 2 of x times x plus 4 equals 5? If not, change it. If you did, keep going. Put me in pause. Okay, let's see how you did. 2 to the 5th equals x squared plus 4x. 2 to the 5th is 32. Equals x squared plus 4x. We have a quadratic, so I want to get it equal to 0, so I'm going to move the 32 over. So x squared plus 4x minus 32 equals 0 is factorable. Plus 8 and negative 4. I get negative 8 and positive 4 as my answers. However, when I take negative 8 and I plug it back in to the original problem, it's going to give me a negative number, so I can't take the log of a negative. So I eliminate negative 8 as an extraneous solution. Final answer, x equals 4. Your homework or classwork, however you want to refer to it, is 12.7 Day 2 worksheet. The sub should have that and be able to give it to you. I hope everything went well. Again, I hope you enjoyed this, and give you a big thumbs up for giving it the old college try. Thanks. Talk to you later.